So we're still on topics relevant to the first section. Now we're going to talk about matrices. A matrix, or matrices plural, is a rectangular arrangement of elements. Dimensions of a matrix is m rows by n columns. The rows is how many equations there are. And the columns is how many terms there are. So this would be like x, y, and then the constant. The elements of a matrix are the numbers inside the matrix. So the elements in this would be 4, -1, 5, 0, 6, 3. An augmented matrix is a matrix derived from a system of linear equations, each written in standard form with the constant term on the right side. When you're adding or subtracting matrices, they have to have the same dimensions. So this is a 2 by 2, this is a 2 by 2. That means you could add them together. If you have a scalar outside, you just multiply all of the elements inside by that scalar on the outside. So 2 times 4 would be 8, 2 times -1 is -2, 2 times 3 is 6, and 2 times 7 would be 14. From there, you would just add the elements that correspond in those same corners. 5 plus 8, 3 plus -2, and so on. And then you would get your final answer right here. Go ahead, pause the video, try this one on your own, and then check it. Okay, you should have got the final answer of a matrix with the elements 16, -3, 4, and 2. So you leave the first matrix alone, and then the second matrix will multiply 3 by each element, all 4 elements. Add the corresponding elements together, and then you get these numbers. So again, on the next page, multiplying scalars, you just multiply the number outside by each of the elements on the inside. Now multiplying matrices is different though. You take the dot product of rows and columns to find each part of the matrix. Note that the first matrices columns must equal the second matrices rows. If they don't, you could just put not possible, no solution. And you can also use the calculator to find these products as well. Let's go ahead and go over that for these. So you want to go to desmos.com/matrix. You click New Matrix, and then you'll type in how many rows and columns it has. The first matrix was a 2 by 3, and the second matrix was a 3 by 2. Once we get those, we can go ahead and type in our elements. So then we can multiply A times B to get this matrix. If we do B times A, we get a different matrix with different dimensions. Now, if you multiply A times B and B times A, they might not always both have solutions. And notice they're also different here. That means that matrix multiplication is not commutative, like the real numbers. Remember, if you had 7 times 6, that's the same thing as 6 times 7. But A times B is not always the same thing as B times A if you're multiplying matrices. If you're in the college algebra course, you will be expected to be able to find these by hand. Otherwise, you will only be expected to use the calculator to find these. Now let's skip to page 10. Put these equations in matrix form. So we have x plus 2y equals 1 and 3x plus 4y equals -1. So as a matrix, we can write this as 1, 2, 1, 3, 4, negative 1. For this one, we could do 4, 2, 7, 2, 1, 1. We only write the coefficients. We don't have to write x or y or z or anything like that. If there's just a variable, you'll put a 1 if it's positive, negative 1 if it was negative. Okay, the next one. Go ahead and try this one on your own. Pause the video. See if you can get this one. And then unpause to check your answers. Okay, we get 4, 2, 1, negative 4, negative 2, negative 1. And then we have a 3 by 4 matrix. So this would be 1, negative 1, 3, 8, 3, 1, negative 2, and then 2, 4, 1, 0. If there's ever an instance where one of the variables is not listed, like if there's no y's at all in the third equation, you would just put 0 instead. So let's talk about putting this into the calculator. So let's go ahead and put this one into the Desmos calculator first. So we have our new matrix. Click new matrix, and then it has 3 equations, 3 rows, and then it has 4 different terms, x, y, z, and the constant. So it's 4 columns. And so then we would type in each element into the boxes. Enter. Okay, so from there, you will find the reduced row echelon form. So we'll click RREF of A. This would be our solution. So then we find the reduced row echelon form, and we have these numbers. So our reduced row echelon form will have 1s and 0s, that's the identity matrix. The last column will be x, y, z, your solutions. So we have 1, 0, 0, 1, 0, 1, 0, negative 1, and then 0, 0, 1, 2. So that means x equals 1, y equals negative 4, z equals 2. There's also some special cases here. If we have this kind of matrix where we have 1, 0, 0, some number, 0, 1, 0, some number, they're all zeros in the last row, that would be infinite solutions. Now if we have 1, 0, 0, something, 0, 1, 0, something, and then 0, 0, 0, something other than 0, like 2, this would be no solution. So that's how you put it in the Desmos calculator. Let's also talk about how to put it in the TI Inspire. Once you turn your TI Inspire on, click on the button with the operations, calculate, and then you'll press menu, 7 matrix vector, 1 create, 1 matrix. You specify how many rows you have, which is 3, how many columns you have, that's 4, and you press OK. And then you'll type in each of the elements into the boxes. And then once you've double checked that it's correct, you'll go all the way to the left side and then type in the letters RREF for reduced row echelon form. And then press the open parenthesis. and then enter. And there you go. There is your reduced row echelon form. X equals 1, Y equals -1, Z equals 2. So here's the instructions for putting these in reduced row echelon form in both calculators. So we have desmos.com/matrix. You make your new matrix, we'll call it A, specify the rows of the columns, and then press the button RREF, and then have A inside the parentheses. And that will give you the reduced row echelon form. For TI Inspire, you'll go to the calculator, menu, 7 matrix, 1 create, 1 matrix, specify your rows and columns. Go all the way to the left and press the buttons RREF and then open parenthesis, enter. If you would like to know more about the pages about matrices, determinants, inverse matrices, be sure to ask me about those. Otherwise, the other notes can be found below this video. Now let's do some of those practice problems inside your packets. We'll do that in the next video.